going to look at an indefinite integral. We have the integral of f of x dx is equal to capital F of x plus c, where f prime of x is equal to the original f of x. So anytime you're taking an indefinite integral, you can find the antiderivative, or think of it as integrating, and make sure you add your plus c, your arbitrary constant. So this first example says evaluate the indefinite integral. We have the integral of x times the cube root of x dx. So we have the integral of x to the 1 times x to the 1/3. So if we combine those, that's going to be 1 plus 1/3, or 4/3. And now we can integrate. So we're going to add 1, which is the same as adding 3/3. And then put the 3/7 in front, and then don't forget your plus c. Okay, for part B, we have the integral of the quantity 3 plus the square root of m squared dm. So similarly to this one, we want to manipulate first to get it ready to integrate. We're going to distribute this out, or FOIL. And we can integrate. Remember, this is just m to the 1/2. So when we integrate, we get 9m. I'm going to drop the 6 down. Then I'm going to work on just the m to the 1/2. So the integral of m to the 1/2, we're going to add 1, so you get 3/2, and then multiply by its reciprocal. And then this last m, you get 1/2 m squared. And then don't forget your arbitrary constant. Sounds so fancy. Don't forget your plus c. And then if you need to clean it up, go for it. Here we have the integral of 3x minus 2 all divided by the square root of x. So I'm going to rewrite this as x to the 1/2. What I like to do here, I call it the heart. When you have 2 terms in the numerator and 1 term in the denominator, you can, what I call applying the heart. So you can split up your fraction into 2 fractions. Remember, you can't have upside down hearts, so only apply the heart when there's 2 terms on top and a monomial in the bottom, or even if there's 3 terms on top and a monomial in the denominator. I guess that's I call it the lotus. But anyways, we're going to split this up. We have 3x over x to the 1/2, so you're splitting these. So on the right side you have negative 2 over x to the 1/2. But to get it ready to integrate, we'll write that as negative 2x to the negative 1/2. So now we can integrate, add 1, and then take that new power and write it as a reciprocal in front. Here I'm going to drop down the minus 2 and do the same thing. We're going to add 1, which is the same as 2 over 2, so you get 1/2, and then you're going to multiply by the reciprocal of this in front, so that'd be 2 over 1. Don't forget your plus c, and then you get 2x to the 3/2 minus 4x to the 1/2 plus c. Okay, next I want to look at definite integrals for our 2 last problems. Here you have the integral from negative 2 to negative 1 of 2y to the 4th times the quantity 2 over y plus 1 over y to the 7th dy. So to get this ready to integrate, we're going to distribute. And so on this first term, you're going to get 4y to the 3rd. And then your next is going to be 2y to the 4th divided by y to the 7th would just make y to the 3rd on the bottom, but because we're going to integrate, we might as well write it as y to the negative 3. And then 4 divided by the new power is just 1. Over here we'll add 1, so you get negative 2. And then you divide the original coefficient by that new power, so you just get negative 1. And then we're evaluating from -2 to -1. So this is really y to the 4th minus 1 over y squared. And now we can plug in our upper limit minus plugging in our lower limit. Then we'll just simplify. Okay, this problem says the integral from 0 to pi over 3 of sine of theta plus sine of theta tangent squared theta all over secant squared theta d theta. Kind of the theme of all of these at this point. We're going to manipulate somehow. So I'm looking at the numerator and I can see that we can factor out a sine theta. So if you factor the sine theta out, you're left with 1 plus tangent squared theta all over secant squared theta. Okay, so the problem is very rigged. Right here you can see the 1 plus tangent squared. So we're going to use the Pythagorean identity secant squared equals 1 plus tangent squared. And the way I think of it is the acronym SIT, S-I-T, secant squared equals 1 plus tangent squared. Even though I know it's 1, I still think of SIT, S-I-T. It helps me remember it. So anyways, where I have 1 plus tangent squared, we're going to replace that with secant squared theta. And then, oh my gosh, how convenient. These guys cancel out. And then you just have the integral from 0 to pi over 3 of sine of theta d theta. So now we can finish this up. The integral of sine theta is negative cosine theta. And we're going to evaluate from 0 to pi over 3. I like to keep, again, any constants to the front. Makes it nicer for evaluating by plugging in your upper limit minus the lower limit. So here we have cosine of pi over 3. So that's going to be a 1/2. Do you remember?